In this lesson, we're going to look at energy transfer and efficiency of electrical devices. So in this simple circuit here, we have a light bulb and a current I is flowing through the light bulb, and there is a potential difference or voltage V across that light bulb. Now we remember that from the previous lesson, the power being supplied to the light bulb is equal to the voltage across the light bulb multiplied by the current flowing through it. And we also remember that in some given time t, then the energy transferred to that light bulb is equal to the power times the time. That's equal to V times I times t. Okay, so for example, if the current flowing through the light bulb is 3 amps and the voltage across the light bulb is 12 volts, then the energy supplied to the light bulb in, say, 60 seconds will be equal to 12 times 3 times 60, which is equal to 2,160 joules. Now the problem is that not all the energy supplied to an electrical device is transferred into useful energy. So for example, in the case of this light bulb, well, we want the energy supplied to it to be transferred into light energy, but not all of that energy is transferred into light energy. In fact, in the old-fashioned type incandescent light bulbs, most of the energy supplied to a light bulb is transferred into heat energy, and that energy is lost, it's wasted. So we can talk about the efficiency of a light bulb or an electrical device. And we can say that the efficiency is equal to the useful energy divided by the energy consumed. So, for example, in 1 minute, 2,160 joules are supplied to this light bulb, but perhaps only 300 joules is actually converted into light. So we have only 300 joules of useful energy. So we can talk about the efficiency of that light bulb as being 300 divided by 2,160, which is equal to, in this case, 0.139. Or if you want to write it as a percentage, as 13.9, you multiply that decimal by 100, that gives you 13.9% efficiency, which is actually pretty typical of the old-fashioned incandescent light bulbs. They simply were not very efficient. Now then, let's have a look at a typical type of problem that involves calculating the efficiency of an electrical device, in this case, an electric motor. So let's assume we've got an electric motor here lifting a weight up the side of a building, and let's say that the weight has a mass of 15 kilograms and that the height of the building is, say, 20 meters, and we'll say that it takes a minute for the motor to lift the weight from the ground up to the top of the building. So we'll write that T, time taken to lift the weight, is 60 seconds. And what we want to calculate is the efficiency of the motor as it does that job. So first of all, we need to know the power that's supplied to the motor. Well, here's the motor circuit, and we'll say we've got a 24 volt battery supplying the motor with a 3 amp current. And so we can say that the energy supplied to the motor, E, equals, from the previous equation, V times I times T. We're talking about 60 seconds here, so that's going to be 24 times 3 times 60, which is equal to 4,320 joules. So in 1 minute, 4,320 joules is supplied to that motor. So the question is, what is the useful work done by the motor in lifting the weight? Well, that's simply equal to, in this case, the change in gravitational potential energy. So the useful energy, or the useful work, okay, that's W, useful work is equal to m times G times H. That's the change in gravitational potential energy of that block, which is equal to, it's 15 times 10 times 20, which is equal to 3,000 joules. Alright, so in 1 minute, the useful work done by the motor is 3,000 joules, but the energy supplied to the motor is 4,320 joules. So we can calculate the efficiency of the motor. The efficiency, the useful energy, divided by the energy consumed. The useful energy is the work done, is the useful work done by the motor. Okay, and that in this particular case was equal to 3,000 joules. That's the change in gravitational potential energy given to the block, divided by the energy supplied to the motor in that 60 seconds. That's 4,320, and that's equal to 0.694, or if you want it as a percentage, then 69.4%. Okay, so this is a very, very typical type of GCSE question on energy transfer and efficiency applying to an electric motor, for example.